Question 9, Part B. A particle is observed as it moves in a straight line in the period between t equals 0 and t equals 10. Its velocity v at time t is shown on the graph above. Copy or trace this graph into your writing booklet. Part 1. On the time axis, mark and clearly label with the letter Z the times when the acceleration of the particle is 0. An acceleration of 0 implies dv dt, or the rate of change of velocity with respect to time, equals 0. And that corresponds to the two stationary points on the velocity time curve here and here. Now I've labelled the points in time where those stationary points occur with the letter Z, directly underneath this stationary point here and directly above this stationary point here. Part 2. On the time axis, mark and clearly label with the letter G the time when the acceleration is greatest. The point on the velocity versus time curve where acceleration is at a maximum, that is, the rate of change of velocity with respect to time is at a maximum, is the point where the gradient to the tangent to the curve is at a maximum. And that occurs roughly at this point here. And I've labelled it on the curve with A max. Now the point in time where that occurs has been labelled on the time axis with the letter G directly underneath A max. Part 3. There are three occasions when the particle is at rest. That is, t equals 0, t equals 7 and t equals 10. The particle is furthest from its initial position on one of these occasions. Indicate which occasion, giving reasons for your answer. In order to answer part 3, we need to consider the signed area bounded by the curve and the time axis. So the area here is positive and the area here is negative. Now, since the curve from t equals 0 to t equals 7 is on or above the time axis, that means the particle is moving to the right, starting at the origin O between t equals 0 and t equals 7. In other words, from here to here. After t equals 7, because the area here is negative, this means that the particle has changed direction and is moving back toward the origin. But it's clear from the graph that the area from t equals 0 to t equals 7, the magnitude of the area specifically, is greater than the magnitude of the area from t equals 7 to t equals 10. So we have a large positive area here, a small negative area here. So what's actually happening is that the particle has moved to the furthest extent to the right, away from the origin, at time t equals 7. After time t equals 7, the particle has moved back toward the origin some distance, but not quite reaching the origin, of course. So here is the explanation. We'll go through this. So the particle is moving to the right, starting at O, between t equals 0 and t equals 7. Now from t equals 7 to t equals 10, the particle changes direction and moves back toward, but not reaching, the origin. Now by observation, the signed area bounded by the curve and the time axis, which represents the displacement of the particle, is maximum between t equals 0 and t equals 7. Therefore, the particle is furthest from the origin at time t equals 7.